Isothermal comparative slow recovery of a system whose consistency is lost upon shearing. That what is your Thixotropy. Whatever I said, I will simplify. Don't worry. I will simplify. We will create the definition. Okay. Example for Thixotropy is pseudoplastic system. If you apply shear stress to the pseudoplastic system, it will become thin. After leaving back, again it will become thick. That what is your Thixotropy. Okay. See what is happening here is, initially we have imaginary layers. In between I have polymers. Applied shear stress, polymer will align in the direction of flow. So it is thick gel. This is thin sol. Again, this is time independent. You applied shear stress, you left it. This will take time. It will take 15, 20 or 30 minutes. Okay. This will take time. Again it will try to reback its original position. Again it will try to regain its original position. Again it will become thick gel. Gel sol gel transformation. Okay. Now the problem is, if your initial viscosity is 100 CPS, when you apply shear stress, you will reduce to 40 CPS. Don't write this CPS. I am writing this CPS to create definition. It is not given there. Okay. But after full recovery, some CPS is lost. Some CPS is lost. And this one is slow process. This one is fast process. Time independent, time dependent. Okay, this one is slow process. And everything we are doing under constant temperature. The temperature should be constant. So, isothermal. Okay, now listen, I will create definition. Okay, isothermal comparatively slow recovery. To whom you are comparing? To this one. Comparatively slow recovery of a system. See, consistency, what is happening to consistency? It is lost. Whose consistency is lost upon shearing. That what the definition. Isothermal comparative slow recovery of a system whose consistency is lost upon shearing. I repeat once again, listen. When you add polymer in water, the polymer will sit between the layers of water and it will also have good interaction with water. Hence it will become thick gel. It will become thick and gel. When you apply shear stress, or like this, it will become thin. So initially it is having 100 CPS, now it is having 40 centiparts. When you leave it aside, slowly it will recover. Slowly it will recover to original position. Again it will become thick and gel. But the consistency is lost. Some consistency, and initially it is 100, now it is 95. Consistency is lost. This experiment you are doing under constant temperature. So definition. Isothermal comparatively slow recovery. Slow. Isothermal comparatively slow recovery of a system whose consistency is lost. See here, it is lost the consistency. Why it is losing all this? Upon shearing. This is my definition. We will see what is textbook definition. Isothermal and comparatively slow recovery on standing of material of a consistency lost through shearing. Somewhat different. but same meaning. I study once again, listen. Isothermal and comparatively slow recovery on standing of a material of a consistency lost through shearing. The right textbook definition. This is my definition. Isothermal, comparatively slow recovery of a system whose consistency is lost upon shearing. Okay, I want you people to learn this. Create your own definition, but it should be related to the textbook definition. Okay, you should relate to the textbook definition. Now, sir, where it is used? Why you are teaching this? Where you are using? If your sauce doesn't have thixotropic property, when you do like this, whole sauce will fall. After doing this, some sauces fall and remaining is there because it is again regaining its consistency. 1. 2. I want to produce an sustained release injection. I want to produce sustained release injection. I will give only one injection. The drug will be released for 2 days. We call it as a depot. I will form an injection depot here. It will release the drug for 2-3 days. We call it as a sustained release injection. For that, what I have to do is, I have to take drugs, add in water, then add polymer to this. When you add polymer to the drug can't escape. So it will escape slowly through the polymer. This slow escape will give me sustained release of a drug. Okay, sustained release of a drug. Now, when I put this in injection, for this it is already thick, but needle is very thin. So it has to lose its consistency to pass through the needle. It has to lose the consistency to pass through the needle. So we have this needle very thin, okay, thin needle. Your thing is there here which is thick. When I press like this, assume if it is not getting thin, gone patient. Doctor is pressing, patient is doing like this. Okay, so that is the problem. So I want this thing to be lose the consistency. When I press here, it will lose the consistency and it will pass through the needle. But if it consistency is not regained, it will be not sustained release. Once it enter into the muscle, again it will reback. See, it will regain its consistency. Again it will regain its consistency. Now it will release the drug slowly. So design formulation, as a formulation scientist, what we do is we incorporate thixotropic property in the injection. If you incorporate the thixotropic property, the injection can be formulated as sustained release formulation. Any doubt here? That what is thixotropic. So how to represent this in a graph? See here, dilatant flow is this one. Okay, again I will rub it. Once I sheared, again I will shear. Now this time its consistency is lost. Again sheared. Remember, if you go away, okay, if you go away from the graph, the consistency is lost. Slowly the consistency is lost. So this what is up curve, down curve, up curve, down curve. Okay, whose consistency is lost. That what is your thixotropy. So wait, sorry. Opposite. Hey, you should tell me now. See here. If I take to the right side, stress is increasing. Means it is gaining viscosity. I want to lose the viscosity. So we call this loop as hysteresis loop. It will tell the history. It will call this loop as hysteresis loop. See here. Sir, why you are drawn this graph? You rubbed the first graph, you draw the grid graph. We'll see what is the difference. I applied the shear stress, consistency loss. When coming back, this time I have to apply less stress compared to the first time. See, first time I have to apply this much. Second time here. First time here. See, third time here. So shear stress is decreasing. Hence we call it as a shear thinning system. It will become thin, thin and thin. But it is regaining its viscosity. Ultimately, if you take pseudoplastic, keep on rubbing it, at one point it will lose all its viscosity. First time it will lose 5 units, next time 10 units, 20, 30, 40. If you are doing, keep on doing that, at particular point it will lose all its viscosity. Okay, that what is your thixotropy.